Hi, my name is Brandon Graisley. I'm a high school math teacher. Today we're going to look again at the roots or zeros of a quadratic function. So here's an example of a quadratic. This is a parabola. Here is the vertex form of its equation. X minus 1 is squared and then minus 4 at the end. You can see there's the vertex, positive 1, negative 4, and I just used the step pattern 1, 3, 5 to draw this quadratic because it has a compression or stretch factor of 1. There's a 1 right there, so which hasn't changed the shape of the quadratic at all. So, but I notice when it crosses the x-axis here, those are two of the points that I was able to plot. And I'm just going to mark down those values here. This is where x equals 3, and of course y equals 0 because it's on the x-axis. And on this side, negative 1 and also 0. So both of those points, that's where what happens when the curve crosses the x-axis, that is when y equals 0. And these 2 points are called the roots or the zeros of this function. Zeros because y equals 0. The value of the function is 0 at those points. So we put in an x value, we get a y value of 0. That's a 0 of the function. Okay? Now with quadratics we have been doing a bunch of factoring, and so I'm going to show you how to use the factored form, this form right here, to find the zeros for any quadratic that you can get in a factored form like this. So let me just go back to the graph for a second. This happens, the zeros occur wherever y equals 0. So to find it, all we're going to do is say, well, what if y was 0? That means that 3, we're going to say set 3 times x plus 2 times x minus 7, set that to be 0. That is, we're going to set y equal to 0. That's what we're doing there. And we're going to look for the places where that can happen. Well, if you look here, what I've got are 3 numbers. This is a number, x plus 2 is going to be a number, and x minus 7 is going to be a number. Those 3 numbers are all multiplied together, and they give me an answer of 0. 3 things, multiply them together, and you get 0. That means that at least one of those, maybe 2, but at least one of them has to be 0. If you're going to multiply stuff together and get 0, something has to be 0 in there. Well, that is not 0. That 3, that's not what we're looking for. So one of these 2 things must be 0. So x plus 2 equals 0, or x minus 7 equals 0. One of those 2 things. Maybe both. Well, not both at the same time, because if I rearrange this, subtracting 2 from each side of the equation, I'll get x equals negative 2, or x equals positive 7. Now looking at my original equation here, you can kind of see where those numbers come from. But these 2 values, these are tell me the roots of the equation, the roots of this equation right here. So I'm just going to write down the roots, or the zeros, they happen at these places, but that means the points are 2, 0, and 7, 0. And if I were to graph this curve, this is an upward facing parabola, so it would have that upwards U shape, and it would cross the x-axis at these 2 specific points. Okay, so let's look at this one down here. Maybe I'll leave that up there for just a minute. For this one, I've got negative 1/2 times these 2 binomials, x minus a quarter and x plus 5. I'm going to do the same thing. For the roots, we're going to set y equal to 0. So that means that negative 1/2 times x minus 1/4 times x plus 5 equals 0. And notice how I'm writing this out, that I'm setting y equal to 0 in order to look for these roots. I'm not saying that this equals this. This is our formula up here, our function, which gives us all of the possible y values. This is going to give us 1 or 2 specific x values. So this is like a special case down here. These 2 things are not equal the way I've written them. Alright, so let's see. One of these 3 things here has to be 0. It's not the number out front, so that means either x minus 1/4 equals 0, or x plus 5 equals 0. Just solving this now, x equals positive 1/4 by adding a quarter to each side, or on this side, x equals negative 5. So the roots are, maybe I'll write the zeros this time, the zeros, are 1/4, comma 0 and negative 5, comma 0, right? 0 and 0. This one down here, this one's slightly different, isn't it? Because we have values in front of the x's that are not 1. That's okay though. We're going to do the same thing. We're going to set y equal to 0 to find the roots. So that means that 3x plus 7 times 5x minus 2 equals 0 when we're going to find our zeros for the function. So that means that either 3x plus 7 equals 0 or 5x minus 2 equals 0. Let's solve this whole side here before we go to the other one. Make a little more room here. Let's see, I'm going to subtract 7 from both sides, so 3x equals negative 7 then. Dividing both sides by 3 gives me x equals negative 7/3. Or, what can happen over here? I'm going to have a similar process. 5x, I'm going to add 2 to both sides. Divide both sides by 5. And so that means x equals 2/5. So my zeros, I'm going to write it over here. My zeros are negative 7/3, comma 0, and, sorry I'm running out of space here, 2/5, comma 0. Okay, well what if you had factored this and you had factored out this 3 and this 5? You would have ended up with this right here. Factoring out the 3 and the 5 gives me 15, x plus 7/3, x minus 2/5. These are the same equation written differently. If I were to distribute the 3 into here, it would become 3x plus 7. If I were to distribute the 5 from the 15 into the second binomial, I'd get 5x minus 2. So if I've done this and I have a nice binomial with a coefficient of 1 in front of each of the x terms, then when I set y equal to 0 to find my zeros, I have 15 times x plus 7/3, x minus 2/5 equals 0. That means that one of these two binomials must be 0. So x plus 7/3 equals 0, or x minus 2/5 equals 0. That means that x is negative 7/3, or x is positive 2/5. Sorry about that. And once again, we'll just leave that right there. So that means the zeros, or the roots, are negative 7/3, comma 0, and 2/5, comma 0. Just like we had up here, it's okay if you factored out this common factor, this number, up at the front here, or if you've left it in this other form with non-1 coefficients in front of your x values. So going back to our graph here, this guy here, we know the formula in the vertex form. Let me just write that out. I'm going to expand that. That's going to be x squared minus 2x plus 1 minus 4. Okay, I'm going to keep going from there, collecting some likeness here. Okay, and now I'm going to factor that into x. Let's see, I need a 3 and a 1, and the 3 will be the negative 1, and there's the positive. So let's set y equal to 0, and that'll give us x minus 3 times x plus 1 equals 0. So x minus 3 equals 0, or x plus 1 equals 0. And check it out, x equals 3, or x equals negative 1 for our zeros. Hey, that makes sense. X equals 3, or x equals -1. So by factoring the equation, I can read off my roots. You can see it's sort of like a sign change if it's nice and simple like this. I can read off my roots and plot them right onto the graph. So now we have the vertex form. It's got a vertex kind of written right in there. We can read it. If we have the factored form, we can read off our roots. And if there's a non-1 value in front of the x's, we got to do a little more fraction work. And we have a step pattern if the number out in front here, the compression